So the third problem is about the active high pass filter. So for the active high pass filter, we're using the op-amp, and the input from the function generator, which is 2 peak to peak, is connected to the input resistor. And then the input resistor is connected to the capacitor. The capacitor is connected to the inverting input of the amplifier. And then there is a feedback resistor, and the output is measured at the output of the amplifier. So for the cutoff frequency, I selected 3 kilohertz, and for the capacitor, I selected the 4.7 nanofarad. And using this formula, I measured or I calculated the resistor. And using this formula, I got R equals 11.2 kilo ohms, and we don't have this value in the lab, so I used a combination of resistors 12K and 180Ks, and those in parallel are equivalent to the 11.2 kilohertz. And since we are using the inverting amplifier, here is the pin out, so we're not using pin number 1, 5, and 8. Pin number 2 is the inverting input. Pin number 3 is the non-inverting input. Pin number 4 should be connected to the negative power. Pin number 7 should be connected to the positive power. And pin number 6 is the output. So for our circuit here, the capacitor should be connected to pin number 2. Pin number 3 should be connected to the ground. And pin number 7 should be connected to the positive input. Pin number 4 to the negative input. And the output is should be connected to the probe, and the 10 to 1 probe, which is pin number 6. And for the positive and negative voltage, using the DC power supply, this is what you should be using in the PSpice. So you'll be using 2 voltage sources. You connect the negative side of the first source to the positive side of the second source, and connect them both to the ground. So the positive side of the first source gives you 12 volts, and the negative side of the second source gives you negative 12. And to get the cutoff frequency, so here's the active high pass filter frequency response. We want the maximum voltage, and since I selected the cutoff frequency to be 3 kilohertz, I can get the maximum voltage like somewhere here. So I choose the 24K to get the maximum voltage, and then I'll divide it by √2, and then I'll decrease the frequency until I get the maximum divided by √2. Now let's see the circuit. So here's the circuit. Here's the input from the function generator. Let's get this back here. Here's the input from the function generator, and the input is connected to the input resistor. And the input resistor, I got 12K in parallel with 180Ks. So here's the 180Ks, here's the 12K, and then it's connected to the capacitor. And then the capacitor is connected to pin number 2. Pin number 3 is connected to the ground. Pin number 4, the blue wire, is connected to the negative power, which is the blue rail here. Pin number 7, the white wire, is connected to the red rail, which is the positive power. And then pin number 6 is connected to the output, and the output is connected to the 10 to 1 probe. And we don't forget the feedback resistor. The feedback resistor is 12K in parallel with the 180K. So this side is connected to pin number 2, and this side is connected to pin number 6. I used those 2 capacitors to filter the noise, if you remember from Lab7. And let's see how I set up the DC power supply. So here's the DC power supply. This is the first output, this is the second output. So I connected the negative from the second side to the ground, and then to the positive of the second side. The positive of the first output gives us positive 12. The negative side of the second source gives us negative 12 volts. And for the display limit, we want it to give us 12K, 12 volts. So for the first, for channel 1, it's 12 volts. For channel 2, it's 12 volts. The over voltage is 13, and for the first channel, it's 13. Now we can apply the power to the amplifier, and then we need to apply the signal from the function generator. So as I said, I want to get the maximum voltage somewhere above the 3 kilohertz, since the cutoff frequency is 3 kilohertz. So I'll start with the 24K, and the amplitude is 2 peak to peak. So at 24 kilohertz, the maximum voltage is 1.80, and 1.80 divided by root 2 equals 1.27. So now let's decrease the frequency. I'll increase the number of cycles here. So peak to peak 2 divided by root 2 should give us 1.26 or 27. So now the cutoff frequency on the function generator is 2.7K, and this is close to the selected one, which is the 3 kilohertz. And this is how we get the cutoff frequency of the active high pass filter in the lab using the function generator and the oscilloscope.